Let's start with fluids. So how do we define that? In fact, we have done these basic definitions, discussed these definitions in the other part of the chapter, which we have already done. That is surface tension. Surface tension हमने किया है पहले से. So this part of fluids is fluid statics and fluid dynamics. So fluid statics means fluids which are stationary or having some bulk motion, means fluid in a container and container is moving, that kind of thing. And fluid dynamics is a different part where fluid itself is moving, that is liquid flow को हम लोग इसमें स्टडी करते हैं. So what do you mean by fluid? Any substance that can flow. Okay. So liquids and gases come under this category. Solids do not. Okay. Then we have ideal fluids. So what is ideal fluid and what are the properties? So basically what is ideal fluid? उसका आंसर आपको यहीं से मिल जाएगा. It is incompressible. Fluid तो हमें पता है, तो what is ideal fluid उसके ये points है. It is incompressible. So ideal fluid is assumed to be incompressible. That means you cannot compress it. Its density remains constant. Okay. Its flow is irrotational. So will not have turbulence. It will go along the same straight line kind of thing, yani smooth lines. Non-viscous. Non-viscous means there is no internal friction between the layers of the liquid. Actually, when liquid flows, it is like layer of liquid. There is another layer of liquid on it. There is another layer. And when these layers move with respect to each other, they oppose each other. That is called viscosity. Of course, we will be studying viscosity in details, but this viscosity is zero in this case. And its flow is steady. Flow is steady means the velocity of each point is constant in time. So these are the properties of ideal fluid. Of course, we are considering only liquids and not gases, even though gases are also fluids. एक दो जगह पे हम gases consider करेंगे, बाकी सब liquids की बात चल रही है, ठीक है? Then some additional properties. Then the first one of it is they do not oppose deformation. That means आप उनको change करो, shape change करने की कोशिश करो, वो change हो जाएगा. The most important one is they are able to flow and they have ability to take shape of the container. These are the things that we need to know about fluid. Now we are studying liquid as a fluid, okay? Not solids or not gases. Now when you study fluids, the first thing that comes here is called hydrostatics. Now what do you mean by hydrostatics? It is a branch of physics that deals with study of liquids at rest, as seen from the observer's frame of reference, okay? Now इसमें सबसे पहला पॉइंट होता है हाइड्रोस्टैटिक प्रेशर. नाउ दीज थिंग्स आर ऑलरेडी देयर इन केमिस्ट्री आल्सो, दो नॉट फॉर लिक्विड्स, दे आर फॉर गैसेस, बट दैट इज ओके बिकॉज गैसेस एंड लिक्विड बोथ आर फ्लूइड्स, तो उसका बेसिक्स तो सेम रहेंगे. हाँ, ऑफ कोर्स सर्टेन थिंग्स विल चेंज फॉर लिक्विड्स. द प्रेशर एक्सर्टेड बाय लिक्विड एट रेस्ट, ओके, इज कॉल्ड हाइड्रोस्टैटिक प्रेशर. एंड लेट्स सी इट लाइक दिस. कंसीडर अ कंटेनर. अभी ये कंसीडर अ कंटेनर, आई नीड टू ड्रॉ दिस थिंग. सो consider a container containing an ideal liquid as shown. Okay, so let's have a container containing ideal liquid as shown. Okay, so now I cannot show that liquid with solid colors because it is very difficult to color this patch. So what I'm doing is there is some liquid. Okay, let's say ideal liquid of density, and let the density be rho, Greek letter rho. Okay, so this is the liquid. Now what I'm doing, let or let डेल्टा एस लिखा है ना, वो डेल्टा एस की बात कर रहा हूं मैं. लेट डेल्टा एस बी एलिमेंटल. पता है ना एलिमेंटल का मीनिंग, एलिमेंटल एरिया, ठीक है, inside the liquid such that point A is at its center. ठीक है ना, तो वो जो डेल्टा एस है, that delta S is our elemental area inside the liquid with point A at its center. अभी उसमें F लिखा है. Now, if F is the force exerted by the liquid, okay, if F vector नहीं लिख रहा हूं मैं, is the force, वेक्टर लिखो, F bar लिखता हूं, चलो, let's make it vector. F bar is the force acting normally, or you can say force exerted by the liquid, okay, normally on the elemental area delta S, then what happens? Then pressure at point A can be calculated as, how do we calculate? Then pressure at point A is calculated as limit delta S tends to 0, F upon delta S. Now remember, this F upon delta S is a scalar quantity. Okay. Okay. Now for homogeneous non-viscous fluids, which we are considering ideal fluids in this case, okay, for homogeneous non-viscous fluids, the pressure at point is independent of orientation of delta S. तो आप उसको उल्टा करो, सीधा करो, कहीं पे भी ले लो, orientation ना, मतलब आप उसको ऐसा रखो, टेढ़ा मेढ़ा कैसे भी रखो, the answer is always the same. Okay. Thus, pressure at a point is a scalar quantity. Of course, we are calculating pressure at a point, which is a scalar quantity. And SI units of this quantity, SI units आपको पहले से पता है, pressure का SI unit होता है, pressure is measured in, pressure is force per unit area, force is measured in Newton, and area meter square, so it is Newton per meter square, also called Pascal. Okay, so that is the way we get hydrostatic pressure. ठीक है, so what we have considered, यहाँ पे एक force which is acting normally, is acting normally to on that area, and मैं उसका limit ले रहा हूँ. Basically I'm taking the limit F divided by delta S, but when delta S tends to 0, so that I can get pressure at particular point. ठीक है, so once I know what is, एक काम करो जरा, इसको आपको note down करना है वो कर लो आप. So now we know what is pressure exerted by liquid at given point. Now we'll have to study variation of pressure with height of liquid column, of course. So let's see this variation of pressure with height of liquid column. Now for this, we'll consider liquid in a container. Okay. So that part remains the same. So consider a container containing an ideal as shown. So this is our container containing liquid. Okay. So this is the container containing liquid. Now what I've done, I'm using XZ plane to show the section. Okay. Z axis is vertical. Let A and B be 2 points, any 2 points. Let A and B be 2 points separated by distance dz inside the liquid of density rho. Okay, na? Dz because I'm going along z axis. Now imagine a small horizontal area S1 and S2. So it is delta S1 and delta S2 here, containing points A and B respectively at the center. जो ऊपर किया था वही करना है, ठीक है? But those 2 points are at 2 different levels, liquid levels. Also delta S1 is equal to delta S2 is equal to delta S. दोनों same. Now consider the cylinder enclosed by delta S1 and delta S2. मतलब ये दिख रहा है, imaginary cylinder बनाया मैंने, delta S1 and delta S2. Let's try to find out the forces, vertical forces. The vertical forces acting on this cylinder are, first force is say F1 जो दिखा है diagram में, which is acting vertically upwards and this force is exerted by the liquid below the cylinder, because cylinder के नीचे भी imaginary cylinder है, but cylinder के नीचे तो liquid ही है, right? So there will be a force exerted by that liquid. Liquid is incompressible है, तो वो compress नहीं होगा, that means वो resist करेगा, ऊपर का weight नीचे आने की कोशिश करेगा, तो नीचे का liquid उसको ऊपर oppose करेगा, that is the logic. F2 is vertically downwards exerted by liquid above the cylinder, and W, which is the weight of the liquid inside the cylinder. Okay, we are using liquid, so I'll change this word here. Instead of fluid, I'll make it liquid. Okay, now once you have these three, let the pressure at point A be P, and the pressure at point B is upwards, so I'm just writing it as P plus delta P, some different value hona chahiye na. So let's assume that it is P and P plus delta P. Then by definition of pressure, by definition, what do we get? We get pressure का definition होता है F upon area. So F1 becomes P delta S, right? And F2 becomes P plus delta P into delta S. Direction मैंने दिखाया है वहां पे. Direction is downwards and upwards respectively. और weight का तो वो simple logic होता है. Weight is mass into gravitational acceleration. So that is density into volume. Volume is area of cross section into height of the cylinder multiplied by G. So W is equal to, these things are very simple then. W is equal to delta S rho G dz, और ये downwards है. If we substitute it in the equation for equilibrium, so for vertical equilibrium liquid कहीं नहीं जा रहा है, so for vertical equilibrium F1, which is acting upwards, is equal to F2 plus W. Then substitute all these three values. So therefore we get this, you may call it 1, 2, 3 if you want. This is 1, this is 2, and that is 3. The W value of W is 3. Then you get this expression from that 1 to those points, 1, 2, 3. From 1 to 3 we get this, right? From 1, 2, and 3. And 3. So from these 3 points we get an equation that looks like this. Now keep on simplifying it till we get delta P or dP, जो भी लिखा है मैंने dP लिखा है तो dP. So dP is equal to minus rho G dz. Now what it tells us? Let's call it 4. What it tells us? Thus, this tells us that as we move up through distance dz, the pressure decreases by rho G dz, where rho is density of liquid, G is gravitational acceleration, and dz is the difference between the levels, right? You have been upwards, you are going upwards. Now consider 2 points, z is equal to 0 and z is equal to h. This can be any 2 points. Then if pressure at z is equal to 0 is P1 and pressure at z is equal to h is equal to P2, then we can integrate it, that above equation, integrating both sides of equation 4. Okay, so if we integrate that from P1 to P2 and from z is equal to 0 to h, we actually get P2 minus P1 is equal to minus rho gh, because dz का इंटीग्रेशन z होगा और z h minus 0 लिमिट सब्स्टिट्यूट करने पर h आएगा आंसर. So what it gives us is P1 minus P2 is equal to rho g h, and hence P2 is equal to, P1 is equal to P2 plus rho gh. Now what it tells us? This tells us that pressure at any point distance h below the liquid surface or the liquid other point in the liquid is pressure at above point plus rho gh. This is what we get. Okay, so this is what we get as expression for pressure. यानी प्रेशर का डिफरेंस आप कभी भी कैलकुलेट कर सकते हैं. इफ यू नो कि वो जीरो कहाँ पे होता है, उस पॉइंट से नीचे की तरफ आप जाओगे तो वो रो जी एच बढ़ते जाएगा प्रेशर. ओके, सो दैट्स व्हाट वी गेट व्हेन वी ट्रैवल वर्टिकली इन अ लिक्विड. ठीक है, now you write down this is a derivation. Of course writing part is important, and when you write it you will understand कि वो terms कहाँ पे क्या हो रहा है. लिखो. If you have any doubts ask me, then we'll go for the horizontal one, horizontal cylinder, और यही same process to find out what happens horizontal. ठीक है, do it fast. The same way, now if we imagine a horizontal cylinder, then what happens? Now I'm not drawing the entire diagram, I'm just showing the cylinder. बाकी सब कुछ same रहेगा उसका. ये ऐसा दिखने वाला सिलेंडर होगा, राइट? That's inside the liquid, remember. So if we have a horizontal cylinder, then forces F1 and F2 due to liquid on left hand side and due to liquid on right hand side. Okay, horizontal forces चाहिए, horizontal equilibrium के लिए. So then there are only two forces, and those two must be equal. So F1 is equal to F2 in magnitude. F1 is P1 delta S1, or delta S is same, and P2 delta S. If you do that, then P1 is equal to P2. That's what we get. And now if we get that, hence what we can conclude, the pressure is same at all points at the same horizontal level. So what happens in a liquid? Pressure varies vertically. As you go deeper into the liquid, pressure goes on increasing by this value, rho GH. While if you move along horizontal points at the same level, then there is no difference in pressure. It's not like gas. Gas का pressure हर जगह पे same होता है. It is same everywhere. But liquids के लिए ऐसा नहीं है. Liquid में जैसे आप surface से नीचे की तरफ जाना चालू करेंगे, the pressure goes on increasing. If you consider that on surface pressure is 0, then as you go below, the pressure goes on increasing by this value, rho GH. Got it? While at horizontal plane, there is no pressure difference. Okay? So what we'll do is, we'll stop here today. Homework for you is just revise this and see you on Thursday, regular timings. Okay? See you on Thursday, then we'll do the next part and we'll start solving problems. And